Assalamu alaikum, dear student. Today our lecture is on addition of angular momentum. Under this topic, we will discuss angular momentum equation and units, rotational momentum, rotational form of Newton's second law, the rotational momentum of a system of particles, the rotational momentum of a rigid body, addition of angular momentum. Now we will see what is angular momentum. Angular momentum is the quantity of rotation of a body which is the product of its moment of inertia and its angular velocity. This is a quantity that is conserved when there are no external force acting. The more massive and faster moving an object, the greater the magnitude of momentum. Now, angular momentum equation and units. Angular momentum is a measure of the extent to which an object will continue to rotate in the absence of an applied torque. MKS or SI unit for angular momentum are kilogram meters squared per second. Angular momentum represented by L, momenta of inertia represented by I, angular velocity represented by omega. So angular momentum is the product of momenta of inertia and angular velocity. Angular momentum or rotational momentum is the rotational equivalent of linear momentum. It is an important quantity in physics which because it is a conserved quantity, which means the total angular momentum of a closed system remain constant. Newton second law of rotation state that the sum of the torque on a rotating system about a fixed axis equal to the product of the moment of inertia and the angular acceleration. This is the rotational similar to Newton's second law of linear motion. In the vector form of Newton's second law for rotation, the torque vector is in the same direction as the angular acceleration. If the angular acceleration of a rotating system is the positive, the torque on the system is also positive. And if the angular acceleration is negative, the torque is negative. This is a figurative description of Newton's second law of rotation, where to achieve maximum torque, a man push a merry-go-round at its edge and perpendicular to its radius. The rotational momentum of a system of particles. During rotational motion, every particle behaves differently. Hence, we calculate the angular momentum for a system of many particles. The angular momentum of any particle rotating about a fixed axis depends on the external torque acting on that body. The angular momentum discussed here is that of rigid body rotating about a fixed axis. The rotational momentum of a rigid body. When a rigid object is rotating about a fixed axis, every particle of the object rotates through the same angle in a given time interval and has the same angular speed and the same angular acceleration, so that the rotational motion of the entire rigid object as well as individually particle in the object can be described by three angles. Using these three angles, we can greatly simplify the analysis of a rigid object rotation. Principle of angular momentum can be described through a right hand rule where the rate of change of angular momentum of a rigid body rotating about a fixed axis is equal to the movement about the axis of the external force acting on the body or external torque acting on the body. I omega is equal to the magnitude of angular momentum. L represent the magnitude of sum of external torques. For addition of angular momentum, takes the example of three masses m1, m2, and m3 rotating about their axis with the radius r1, r2, and r3 respectively. Angular velocity is represented by omega 10, omega 20, and omega 30 respectively. Angular momentum of masses 1 is calculated first, and then the summation of three angular momentum provide total angular momentum of three masses. Thank you very much for your attention.